enjoy the next presentation.
Right, ladies and gentlemen, welcome back to our next tech session. The title of the presentation is Journey to Sustainable Water Management. It will be presented by engineer Dr. Teo Yat Han. She's from the University of Kebangsaan, Malaysia. She's currently the lead for water solutions and water technologies at Research Center for Sustainable Process Technology at University Kebangsaan, Malaysia. Research activities are principally dedicated to the field of water purification and wastewater treatment. She's been involved in a few industry, academia, collaboration projects with the likes of Sime Darby Research Center in Berhad, Indah Water Consortium, Infineon Technologies in Berhad, and Teleworks Technologies in Berhad, mainly on wastewater treatment and water recycle and reuse. To date, she had published more than 55 research articles in journals, 28 conference proceedings, 4 books, 4 book chapters, 4 articles in mass media, and she also currently owns 2 patents. Engineer Dr. Teo, please start your presentation. Thank you very much. You have to unmute, Dr. Teo.
Thank you, Mr. Kelvin, for the nice introductions. So I will start my presentations for today. Good morning, everyone. Today's my presentation's title will be on the topic of Journals to Sustainable Water Management. And this is my real experience to share with you guys. Before I start my experience and sharing, let us take a look on the current challenging issue on water. And here is the topological distributions on the water scarcity. And this is the estimated or forecasting for the scarcity in year 2025. And there is many reports that have been reported either through Google's or through the media mass. As we can see that there is more than 370,000 results of the searching on the water scarcity. And we know that water is not only the challenge for Malaysia, it is also a water war or a challenge to the world. As a quote by the Thomas, we know that we never know the worth of water till the well is dry, which means that most of us didn't really appreciate all the resources that we currently have until one day we face the issue. And hopefully this will not the problems that we face in Malaysia. Water is also not an oil. If we finish the oil, we can use other energy resources like the renewable energy to replace it. But if we destroy water source, life has no meaning. So for the water source, we have plenty of water source like lake water, sea water, river water, groundwater, and well water. And for the distributions of water usage, we know that about 70% of it is used for the agriculture, 19% is used for industry, and about 11% is used in domestic. However, because of the water's limited of we can utilize is very limited, there will be a potential for the water crisis. At the same time, the processed water from this industry can cause to pollution. So I would like to introduce to you about the sustainable water management concept. The sustainable water management is simply the concept of managing our water resources while taking into account the needs of present and future users. So this is the distributions of the world's water. As I say, our world or planet, they have plenty of water. In ocean itself, it consists of 97%. However, the fresh water that we can utilize only 3%. And out of this 3%, the accessible surface fresh water, which is only 1%. Can you imagine that? And in Asia, especially, the water use is the highest among the world. As I summarize here is, only 0.01% of the world's water supply is accessible without seawater desalinations, and therefore water management is necessary. As an alternative of water resources, we can use the seawater by going through the desalination process. However, there is also another option that we can look into is the recycling process of water recycle and reuse. There are several opportunities for water reuse, either through the basic treatment, then the water can be used for agriculture and golf course irrigations, landscape watering, recreations use, toilet flushing, fire suppressions, and from basic treatments and go forward for the advanced treatment, it can even use for potable supplies, reservoir augmentations, and groundwater recharge. And this is a summarized table on different applications of water reuse, wastewater reuse assessment. So I would like to introduce to you a technology that used for water and wastewater treatment, which we call as membrane technology. So membrane technology, in simple words, it is just a semi-permeable membrane that used in a system whereby it used the physical separations process to separate the solute particles, whereas allowed the water to penetrate through the membrane pore to achieve a clean water in the permeate site. So membrane, they have different categories. We have microfiltrations, ultrafiltrations, nanofiltrations, and reverse osmosis. It depends on the operating pressure of that particular membrane as well as pore size of the membrane. And each of the membrane, they also have different rejections ability. The rejections ability is increasing from microfiltrations, and the highest one will be the reverse osmosis. And this is the development pathway of membrane technology. And here is the example or the view or the photograph of the membrane and how does it look like. And this table shows you the rejections ability of different membranes and what are the size of the materials that it can reject from each types of membrane types. So let's take a look on the cost of water in USD. So each country, they have different costs of water. So in Malaysia, we are comparatively cheaper. But have you ever think about how much we have to pay for a bottle of water, let's say when the cost of that water is increasing due to the scarcity issue? And this can be a good business. So for us, especially as a researcher, we know that the technology is ready. Most of the technology already developed from the R&D perspective. And there is an industry that really ready to tackling on this technology. And why not? Here comes to the collaborations between the technology and industry to create a larger revenues for water and wastewater industry. So let's take a little bit more close look on our nearby country, Singapore. The project in Singapore, the New Water project for water recycling. This is the process of a new water in a Singapore treatment plant, and they are using membrane technology for them to achieve the water reclamations. The treated used water is passing through the membrane. The membrane is here. Both they are using microfiltrations membrane and ultrafiltrations membrane for disinfections. And at the end of the day, they were able to obtain the high-grade reclamations water. So at this standpoint, I'm starting to ask myself, is there any possibility that Malaysia also have this capability to do the same thing or even better? And here start my journey to the sustainable water management. So the report from Singapore Water Reclamation Study Expert Panel reviews finding, it shows that the physical, chemical, and microbiological data for new water are well within the latest requirement for US EPA Drinking Water Standard and WHO Drinking Water Quality Guidelines. Exposures or consumptions of this new water, it does not give any carcinogenic effects or estrogenic effect on the fish. New water is considered as safe for potable use based on the comprehensive physical, chemical, and microbiological analysis of new water conduct over 2 years. And with this, I start my projects, collaborate with Indah Water Konsortium Sendirian Berhad. Indah Water has approached me for a project whereby they would like to give some adding values for their treated sewage or treated bioeffluents. So by having added values for their treated effluents, then we go through a study on the effective and economic disinfection study, because we would like to kill the bacteria inside the sewage water so that the treated water after the treatments can be safe for the human's body contact. And this is the connected sewage system or service. I believe that no need to go into deeper. And we know that Indah Water Konsortium Sendirian Berhad, they serve for Malaysia, and is about 65 million liters of sewage has been treated a day. And let's think about waste to wealth concept and how much that we can gain from this waste to wealth concept. So here I started with my planning, whereby I have several treatments strategies for this Indah water bioeffluents. It could be a single treatment of UV chlorinations, microfiltrations, and ultrafiltrations, or integrated process of GMM UV, EMM UV, and so on. So this is the system flow diagrams and how does it looks like. So it can either use for single treatments or it can even use for the integrated system. For the treated effluents or permeate I collected from this system, I also benchmark it with the water reuse guideline, the US EPA restricted area and unrestricted area, along with the Singapore new water quality and the Singapore grey water quality. So this is the data that I obtained, or the summary of the research output, whereby I'm using different kind of single disinfection unit and integrated disinfection system. And I found out that all this, the red color blank box, are the system that able to achieve US EPA restricted area, and out of it, this PVDF membrane and PES membrane is having the cheapest cost. So this is the cost calculated, including both CapEx and OpEx. On the other hand, I also tested it with the unrestricted area quality, and I found out that this technology with the red blocks are able to achieve unrestricted area water quality, and with it, the lowest cost still achieved by PVDF and PES membrane. Another project that I would like to show you or share with you is the Sime Darby Research Sendirian Berhad project on water recycle and reuse. We know that Sime Darby is the largest agriculture industry in Malaysia, and they discharge a lot of wastewater from it, which we call it as palm oil milk effluent. This is the single largest industry wastewater in Malaysia and often cause some problems. Because of this, many countries have banned palm oil and it creates some of the issue. So we would like to create a zero waste technology for Sime Darby. And for today, I will not go into details for other technology, whereby I will just focus on the last stage of it for the palm oil milk effluent on the water recycle and reuse. Sime Darby had told us that they would like to achieve the water with the quality of boiler feed. Therefore, we designed a process, including an integrated process of biofilm pretreatments, the media filtering system, the ultrafiltrations membrane pretreatments, and lastly is the reverse osmosis membrane. Sorry. So this is how the system looks like. The layout of the system, it has 3 stages, as I mentioned. We have the pre-treatments. Sorry. We have the biofilm pre-treatments. We have the sand filter, activated carbon filter, and ultrafiltrations pre-treatments, along with the membrane treatments as the last stage. And from lab scale study, we managed to convert it into pilot scale, and we even optimized the process in the Sime Darby plant. This plant has been built in Batang Berjuntai, Kuala Selangor. And this is the boiler feed water quality that we obtained at the end of the project. So we benchmark the parameters of the waters with the boiler feed water. So after RO, we managed to obtain the water quality, which is very close to boiler feed water quality. And this is the photos taken in the pilot plant that we built. So the deliverable of this project is we managed to design a pilot scale membrane treatment system integrated with pre-treatments, and this integrated pilot plant managed to produce the water with recycled water quality in a boiler feed grade and under optimum operating conditions. This is how the water quality looks like after each stage of the treatments. And here is the summary of the project whereby we have different stages of it. And this is the membrane filtration system with the quality dimensions. And this is the development phase of this project from year 2011 until 2020, whereby I already mentioned to you that we are start from a lab scale, theoretical study, and upscaling until a pilot scale. And here is the plan, the pilot plan that we have. So the next project is with Infineon's technology Sendirian Berhad. This project is on silicon recovery with enhancement of wastewater treatments. So we know that other than palm oil industry that I mentioned just now, Malaysia also export about 37.78% of E&E product. And semiconductor industry play a very important role in this E&E industry. And what is the conventional treatment process in semiconductor industry is they're using coagulations process by adding the coagulants into their wastewater in order to get the flux, and they will sedimentations. After that, they will go through the filter press system to press it, get the sludge, to separate the sludge as well as the treated water. However, there are some environmental issues and challenges that has been faced by this semiconductor industry is because of the solid waste disposal, which caused them some high amount of capex that they have to pay the solid disposal charge from time to time. They have to use the expensive chemical coagulants for the process, and then it leads to high operating costs. And the treated water also having low quality, whereby this water can only directly discharge into river without recycle and reuse. So this company comes to me and say, hey, is it possible that we want to make our industry more sustainable and greener? And I say, yeah, possible. So we come up with the ideas that we are checking. Because I'm saying that there are the precious materials in their wastewater. Why don't we have a system that has two benefits in one system? The silicon particles inside their wastewater is precious materials to them. So I say membrane can do that. With a membrane filtration system, your silicon particles can be recovered for reuse for any other purpose, like you want to convert into a vapor, or you want to sell it for a solar panel company. And at the same time, the treated water will having a higher quality whereby you can reuse in your plant for any other purpose. So we agree with this project, and it comes to a point that we design the system to do a lab scale study with different membranes, membrane A, B, C, D, E. Then we would like to check the efficiency of the membrane. And here is the data from the projects, whereby we found out that this membrane is having a highest rejection efficiency, which is more than 90%. And the collected silicon particles from membrane filtration process even as high as 99.99%. And this is the videos I'm showing you, the water that we collected from semiconductor industry, which is gray brackish in color, and we managed to produce a clean water from there. All right, so next one, we already identified, or we already have several projects on industry parts. So for the industry applications, go towards the industry applications, we need research to support. So here are the research or the R&D behind this industry project. So one of the methods I would like to share with you, the technology that I use in the water treatment is membrane technology. But is there any obstacle for this technology, and how are we encounter with this obstacle? So one of it is the in-situ colloidal precipitation method. This is the method that developed by me and my team, whereby the conventional treatment method, they just using the polymer solutions to produce the membrane. However, membrane might facing the problems of foulings, and the fouling will be shorten the lifespan of the membrane. And this is also the reason why most of the industry players keep on criticize, oh, membrane is not sustainable, membrane is having a high cost, because they have to keep on changing the membrane once fouling is very severe. So for this technology, nanoparticles is incorporated into polymer solutions. And from this in-situ colloidal precipitation methods, we managed to produce the membranes that is less fouling. So this is the blending methods, the conventional one. Then the blending will create some defects on the membrane surface. However, for the in-situ colloidal precipitation methods, whereby we are using this kind of mechanism, you can see that the nanoparticles can distribute evenly at low concentrations. There is no issue of agglomerations. There is no issue of defect on the membrane surface. The other technologies or the R&D projects that I'm working on with my PhD student is on the optimizations. The optimizations can be done not only on the membrane formulations, it can also done on the membrane filtration process. So this is the membrane filtration process that my student is working on. We are using the cross-flow filtration system for the treatment of palm oil meal effluent. And this is the novel membrane that has been developed from the system, whereby this membrane is having an active anti-fouling control, whereby there is a repulsive charge on the membrane surface, and we know that most of the foulants are in negative charge. So these foulants can be rejected or repelled from the membrane surface to achieve the active anti-fouling properties. And this is the RSM modeling that I'm using in order to optimize the process. And we found out that from this RSM study, then we managed to reduce the fouling effect, and we can even improve the membrane performance in 179 to 186% of it. And this is another R&D project I would like to share with you in another perspective. Yeah, when we talk about the green and sustainable technology, usually the industry partner will tell us, can you give me a quantitative data shows that your technology is green and sustainable compared to the current technology that I have? How can I prove it? We need a holistic approach for the system. So the holistic approach that we use is the life cycle assessment, whereby the life cycle assessment is an environmental assessment tool for evaluations of impact that a product has on the environmental over the entire period of its life. So because the membrane is just involved the operation phase, I will just utilize the methodology of gate-to-gate approach. And the operational phase is the phase presented in the greatest impact as compared to construction. And this is the diagrams that I showed to you previously for the Sime Darby project. The same projects that I use for this life cycle assessment study. And for this Sime Darby project, I can manipulate it and with different array or combinations. So we can bypass some of the system, and I'm studying different array. How will the environment impact looks like? And for this life cycle assessment, the interesting things is you can see from the system what is the climate change impact, what is the terrestrial acidifications impact, marine eutrophications, and human toxicity impact for each of the system. And from the system here, you can reach a conclusion or a comparison. All this system will produce a boiler feed water. and different array has been utilized for this system, and which system actually is more economy friendliest. So as a summary for this life cycle study for the Sime Darby project, the electricity consumptions, we found out that is the domain factor. So array 1 has the greatest impact towards life cycle impact categories because it involves many unit operations and it requires high electricity consumptions, process water utilizations, and some chemicals use. And for array 4, comparatively, it is the most economy-friendly operating process in treating the anaerobic digester POME to achieve the boiler feed grade treated water with less amount of electricity use. Other than that, the membrane technology that I mentioned to you previously, either from the industry applications perspective or the R&D perspective, are more towards as one advanced treatment. Other than the advanced treatments, I'm also unlocked the potential of biomass as an adsorbent for pre-treatments. So again, this project is collaborate with Sime Darby, and utilize their POME as well as the palm kernel shell in order to produce or to synthesize.
Sorry, Dr.
Yes.
Teo, we are running short of time. You have 2 to 3 minutes, and then we have a quick Q&A. Yeah.
All right, thank you so much. So I will just keep it. So this is the process to convert the biomass into the adsorbent and the treatment qualities that whereby we achieve the clean water quality. We even tested with the industry wastewater, and this is the quality that we achieve. And the challenges of the municipal water reuse, we know that the challenges is acceptance by the public, minimize the cost, as well as any incentive by the governments. So just to share with you the collaborator for this, the project teams and the collaborator with me, some of the books that have been published from the research output, and to introduce to you my team, the mentors, and thanks to family supports, as well as to introduce to you CHESPRO, the research centers that I'm currently in. And this is the team that I'm leading. Other than this team, we also have others team members like the smart technologies, the intelligence system, as well as the energy, renewable energies part. And also to promote to you the conference that we are going to hold at the end of this year. That'll be the end for my today's presentations. Thank you so much.
Thank you, Dr. Engineer Dr. Teo. There's a lot to take in. It's very informative, and right now we have no questions from the floor. But I would like to ask you something, because I have some experience using a membrane, but mainly in the rural water supply situation. So fouling is something that we have to overcome. Either by constant backwashing and then chemical cleaning, but that presents a unique difficulty or challenging situation for rural environment, because it may take a day to get there and power is not available and such. So in your presentation, you mentioned that you have am researching innovative method to reduce the fouling by putting charges on the of course I don't know the details of the membrane manufacturing, but can I ask at what stage is your research? Is it have you collaborated with any manufacturers to scale up your research method?
Yeah, currently the manufacturing of the anti-fouling membrane is not something new. They are already well established in R&D area. The only issue that we are facing now is not many industry takers that knows about it, or no many industry manufacturing industry that willing to invest on this kind of one company that approached me recently from China. They are interested to convert or to convert my lab skill study, the formulations into the real membrane. However, we're still discussing and looks for the potentials of collaborations. Do you have any, do you know any membrane manufacturer in Malaysia? Because as what I know is there is in Malaysia. They are only the supplier or end user.
I think right now the membrane manufacturing industry is in Malaysia. There is none. I think mainly they are in China. We've been working with membrane since 2008, 2009, and I think our experience is mainly with Chinese manufacturers, especially on the large scale. But there are some Japanese manufacturers, Asahi Kase. So we work with some of them, and obviously with Chinese manufacturers. I believe they may be interested to know, because in terms of application, I think membrane fouling is one of the main cause factor in the life cycle of a membrane, and it determines the life of the membrane, and also hence the replacement cost of the membrane, which stops it from being used more widely. So what you are researching, I think, is really addressing the key issue in terms of membrane application. So
yeah, it is actually the biggest obstacle in membrane technology field. However, I'm trying to deliver the message to clear the mindset of the industry player that membrane is not something bad. Any technology that is an advantage and disadvantages. Just the point that how we are tackling to reduce the disadvantages of that particular technology. And when the R&D is there, all of things are well established in academic or R&D field. Just the thing is how we are going to bridge the gap with the industry and selling this kind of concept to industry, and industry willing to take it in order to make our water industry more sustainable for the future. Yeah.
Yes, I think what you are doing gives great value to the sustainability of water recycling and reuse. So fortunately, we have reached our time slot for the presentation. So we'd like to, on behalf of the organizers, thank you, Engineer Dr. Teo. We hope we can get in touch to share more information about membrane.
Sure,
right.
sure.
Thank you very much.
Thank you so much. Thank you, Mr. Kevin, and all the hosts. Thank you.